Hello friends. So last class we discussed about the 3 to 8 decoder. So how can you design the 3 to 8 decoder, and after that if you have the different kind of the functions, boolean expression, how can you design those boolean expression without using the basic gate, but we can use the different kinds of the decoder, right? So now the first this is like question is that you have to design the full adder using the decoder, which is 3 to 8 decoder. Okay, 3 to 8 decoder. Now, first for that you have to check the truth table for full adder, right? So for full adder you have the 3 bits. You have to do the addition for 3 bits. So first I am writing 3 bit here. Total how many combinations? Total second 7 combinations we can write. And what are the outputs for full adder? Sum and the carry. Okay, so if we add these 3 0, it sum will be 0, carry will be 0. So I am writing all the outputs. Here it is 1 and 0, 1 0, 1 1. So if we add 0 with 1 and again 1, you will get sum 0, sum 0 will get, and carry will be 1. Okay, so all this thing I am writing. So again you can see 1 plus 0 1, and again 1 plus 1, it is 10. 10 means binary equivalent is the 2. Okay, so 1 plus 1 in decimal it is 2. If you convert it into the binary, it will be 1 0. So 0 will be the result and 1 will be the carry. So this thing I have already discussed, just I am writing the truth table here. So here it is 1 1. Okay, now if you want to write in the form of the mean term, what is your S? S is mean term. So you have this is 0 1 2 3 4 5 6 7. Okay, so your sum is 1 in for which combination? 1 2 4 and 7. And if you want to write the carry in mean term, so you have to check your carry is 1 for which combinations? 3 5 6 7. 5 6 7. Now if you draw the 3 to 8 decoder, you have the 3 inputs. So if this is A, B, C, my 3 inputs, you will get total 8 outputs, right? Okay, so it is, suppose it is Y0, Y1, Y2, 1, 2, 3, 4, 5, 6, 7. Okay, total 8 lines are there. This is Y7, right? So we have already discussed that Y0 means it is like mean term M0. Okay, Y7 means it is like mean term M7. Okay, so if you want to design the sum and carry, okay, for full adder, sum how will get if you take mean term 1 2 4 and 7. So this is my mean term 1 2 4 and 7. From there you will get, if you do the if you add the OR gate, you will get sum here, right? And for carry I have to take mean terms 3 5 6 7. So these are my mean terms. I have to take 3 5 6 and 7. Again you have to do the OR operation. Here you will get you carry. Okay, so this is the full adder using 3 to 8 decoder. Now come to the next is the, so using 3 to 8 decoder you can design any kind of the boolean expression like full adder also. Now if you have the 4 bits, right, then you come to the, then you have to come to the higher number of decoder, that is 4 is to 10 decoder or 4 is to 16 decoder, right? So full adder means 3 bits. So by using the 3 to 8 decoder you can design the full adder. And if you have in boolean expression which consists of only 3 inputs, for that you can also design the 3 to 8 decoder. Next come to the 4 to 10 decoder. Okay, so 4 to 10 decoder, It is mainly used to convert. Decoder means normally the binary or coded input to the readable output, right? This is the decoder. So 4:10 decoder, for which purpose we have to use BCD to decimal number. So readable number is the only decimal number is readable for human, right? So BCD. BCD means it's like a binary number which consists of 4 binary digits. Suppose if I have 8. 8 means 1 0 0 0. So 1 0 0 is the BCD number for 8. It is not binary number, it is the BCD number. Now if you want to write 12. Okay, if you write 12 in the binary, I have already explained this thing, right? In binary it will be 1100. It is binary. Okay, so if you convert 12 into BCD number, each digit which inside the 12, each digit have to convert into the binary number. So 1 if you convert, it will be 001. So each digit should contain the total 4 digits, binary digits, and if you convert 2, it will come to the 0010. So this entire is the BCD number for 12. So if you are giving the BCD number to the computer, so for human interpretation you need the decimal number from BCD. Okay, so how can you convert the BCD number to the decimal number? You have some procedure. So I am telling that if you see this kind of the number, you can convert by using the mathematics. You can convert this number to the decimal number. But in computer there is no calculation mathematics, right? Some logic gate should be there. So inside the decoder, you will have to put some logic gates. By using the decoder and by using some logic gates, you can design a converter which can convert BCD number to the decimal number, right? So okay, so I am writing the BCD number to decimal. So in my input section, BCD numbers. BCD means total 4 digits, right? So A, B, C, D. Okay, so I am writing all the numbers from 00 to 9. After 9, there is no concept of the BCD number, because after 9, if you come to the 10, 10 consists of 1 and 0. So 1, that individually will give a one binary number from 1, and you will get some binary number from the 0. Okay, you cannot directly convert 10 into the binary in case of the BCD, right? So I am writing number from 0 to 9. Okay, so in 4 bits are there, you can write for total 16 combinations, but I will not write the total 16 combinations. I will only write the total 4 combinations, right? Sorry, total 9 combinations from 0 to 9. Okay, so this thing I am writing here. Seven, 8, 9. Okay, so after 9, if you want to write the total 16 combinations, after 9, you will have the 10, 11, 12, 13, 14, 15, 16. Okay, so so after 9, whatever combinations are there, so your output will be, all the output will be 0 from 10 to 15. Okay, so what will be your output here? So so for 4 input means I have to use the 4 to 10 decoder, right? So 10 decoder means total 9 digit you will get. Suppose if you are giving 0, you will get 0. If you are giving 0001, you will get 1. So total 9 output lines, total 10 output lines you have to get from the 4:10 decoder, right? So that means how many output lines should be there? Total 10 output lines should be there, right? So Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7, Y8, Y9. Okay. So if I am giving 000, only my Y0 will be 1. Other all the time should be 0. If I am giving 001, so only Y1 should be 1 and other term should be 0. In this way, when I give the 9, 1009, So all other terms should be 0, 0, 0, and the y9 should be 1. So what will happen if I give 1, 0, 1, 0, 10, okay, into 4 is to 10 decoder? So there will be no output. When I am giving 10 to 15 number digits to the 4 is to 10 decoder, output will be 0. And before that, if I am giving 9, y9 will be 1. If I give 8, y8 will be 1, like this way. Okay, so this is about the 4 is to 10 decoder. Okay, so if you want to write the block diagram, how can you write? So here it is 4 is to 10 decoder, total 4 input lines A, B, C, D, total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y not 2, Y, sorry, Y 9. Y not to y9. Okay, suppose you have one function like that, a f a b comma c comma d summation mean term 4 7 9. Okay, so how we will do? You have to take input from 4 5 6 7 and the 9, and then you have to add the OR function. Okay, so this is my function f. So you can design any kind of the Boolean function by using the 4 to 10 decoder, right? So if you have some minterms above 9, so that time you cannot use the 4 to 8 10 decoder, you have to follow the 4 to 16 decoder. So up to 9, you can use the 4 to 10. If the maximum minterms are there, that is 7, you have to use the 3 is to 8 decoder. Or here if it's given the 3 input variable. If 4 input variables are given and maximum minterms contain 9, then you have to use the 4 is to 10 decoder. If any minterms are there that is above 9, then you have to add the 4 is to 16 decoder. Okay, so this is the 4 is to 10 decoder. If you give any kind of a BCD number, you will get the decimal number at the output. Okay, next come to the 4 is to 16. 4 is to 16 decoder, that is mainly used for if you want to convert the hexadecimal number to the decimal number. In hexadecimal number, there are total 16 distinct numbers, right? So 0 to 15. Okay, so if you give the 0 to 15 in the form of the binary, you will get the decimal number from 0 to 15 at the output side if using the 4 is to 16 decoder, right? So these 4 inputs and total 16 outputs, y0 to y15. Okay, so I'm just writing here combinations, 4 combinations. Okay, so A, B, C, D. Okay, so total 16 combination I am writing here. So first I will write 16 combination. So it is very difficult to design the 4 is to decoder by using normal gates. Okay. So if you know the 2 is to 4 decoder and the 3 is to 8 decoder, by using 2 is to 4 decoder and the 3 is to 8 decoder, you can design the 4 is to 16. So for that I am just writing the truth table here. I will write the truth table in the short form. Okay. First I am writing the input lines, how many total 4 inputs are there, the total 16 combination you have to write. Okay, so here I am writing the truth table. 6, 7, 8. So I am putting 8 0, then 8 1. Okay, 0 1 0 1 like this. Okay, So when I give 000, then y naught signal logic 1 data will get from the y naught, right? So here I'm writing y naught, y1, like this way I'm not writing. I'm not writing the entire outputs, so I'm just writing this thing. Zero, y0, y1, y2, y3, y4. Okay, that means in this case logic 1 will get from the y naught, in the next case I will get logic 1 from the y1, like this way, right? So first I am showing you how can you design the 4:8 decoder using 3:8 decoder. Okay, so how can you design? First so maximum output here from this 4:16 decoder, how many output lines will get? 16 output lines will get. But from the 3:8 I will get the total 8 output lines. So how many 3:8 decoders are required for designing the 4:16? Okay, so for that first I have to divide the 16 by 8. Okay, you will get 2. Now you can see 2 cannot divisible by 8. Okay, that means only 2 numbers of, this is the number of decoder. Okay, that means only 2 numbers of 3:8 decoders are required. Okay, so I am putting 2 number of 3:8 decoder. So in here 8 output lines, so it is y0 to y7. Okay, here it is y8 to y15. Okay, now in these two cases I can tell that 3 input lines only I can give. Okay, so these 3 input line I used to put the LSB side. Okay, B, C, D, B, C, D. Okay, now you can see these things are common. If we remove the A portion, this 0 to this 0 to 7, y0 to y7 and y8 to y15 are same. Okay, so it is 0 to 7 only, you can see it is also 0 to 7. That means only A is different for this combination. So if your A is 0, then y0 to y7 data will be selected, right? If is A is 1, then y to y15 data will be selected. So here I have given BCD, BCD, okay? Because this BCD, based on this BCD combinations, so y0 to y7 data is also selected. Based on this BCD combinations also y to y15 data are selected, right? So now what about the A? So if A is 0, this above decoder will be selected. If A is 1, the below decoder will be selected, right? From this truth table you can understand, right? So I am giving A, but on NOT gate I am mentioning here. Here I am directly connected A. So these two lines are acting as a enable line. Okay. Now you can see if I give A as a 0, right? If A is 0, here it is 1. Okay, if A is 0, here it is 1. It is 1. Enable line 1 means this decoder will be selected. When you give this 3 input combination 0, 0, 0, 0, 1, this 1, y0 to y7 data will be selected. Now if your A is 1, this will be 0 and this will be 1. So this will this decoder will be disabled and this decoder will be enabled. So when you are giving A as a 1, then y to y15 data will be collected from the 4:16 decoder. Okay, so in this way we can design the 4:16 decoder using 3:8. Right. Next is the how can you design using 2:4 decoder? So again I am dividing 16 by 4. If you divide 16 by 4, you will get 4. Okay. And again if you divide 4 by this 4, you will get 1. 16 I am dividing by 4, I am getting 4. Again this result I am dividing by 4, I am getting 1. So total 4 plus 1, 2 is to 4 decoders are required. Okay. So first I got 4. Okay. So 4 I am placing here. Next I got the 1. So 1 I am placing here. These are the 2 is to 4. All are 2 is to 4. So by default I can put total 4 output lines and 2 input lines. Okay. So these are my final outputs, right? Total how many combinations? 15. Y02, Y3, Y42, Y7, Y82, Y11, 8, 9, 10, 11, Y12 to Y15. Okay, what about this thing? Right, here also the 4 output line will go get. Okay, here 2 input lines, right? Now here you can see when the y0 y3 data will be selected, right? Now so y0 y data, when it will be selected, when we will give the 0 0 0 1 1 0 1 1, this data will be selected again. So for this case a b both are 0 0 0, right? Now come to the y4 to y7. So this cd are same for this and for this. The ab is changed here, 0 1 0 1 0 1 0 1. Again, if you want to come, if you come for y8 to y11, CD data is same. Only the AB data is changing, right? So for all cases, CD data is same, but AB data combinations, these are changing. Okay, that means this CD I can put here because these are same for all the cases. Okay, now I'm connecting this all the output with all this decoder. Okay, now here I am putting, so if CD I have connected here, I can put AB here. Now I will check whether the so according to combinations I am getting all outputs or not. Suppose I am giving AB 0 0. If I am giving A 0 0 from this decoder, this data will be 1. Okay, if this is 1, this decoder will be selected, other decoder will be disabled. Okay, so that means when I am giving 0 0, y0 to y3 data is coming. Okay, so according to truth table it is matching. Now if I give 0 1, 0 1, then second line will be select 1. Okay, that means this enables the second decoder, this decoder. Okay, then I will get y4. If we give 4 combinations, accordingly I will give y4 y7, y4 to y7. In this way, for 1 0, this will be decoder will be enabled, and for 1 1, the last decoder will be enabled. So in this way you can design 4:16 decoder using the 2:4 decoder. So these are all about the 4:16 decoder and 4:10 decoder. So next class I will start with the encoder. After that we will come to the sequential circuit. So please like, share and subscribe my channel. Thank you.